Hi, welcome to the Calculus 1 lecture series. And we are in the unit number 3. And in this unit, we'll talk about the application of differentiation. And this is our lecture number 22. We're going to talk about the summary of the curve sketching. So prior few lectures, we talk about how to determine the functions increasing, decreasing, concave up, concave down, and where they have the asymptotes, those things. And now we're going to combine all the knowledge we learned and see whether we'll be able to, sketch the curve and based on all this calculus skill and the concept here. Okay, so let's go ahead and go to our worksheets here, the lecture notes. And so for the, I put like a brief summary, like in here, and we talk about how do we the curve sketching, useful information. So I put like the few items here, and every time when you kind of sketch the curve, those can be your general guidelines. Doesn't mean that every items you need to have something. It's just that those are the things you can consider, and then you'll be able to get a pretty good the ideas, what is the graph looks like. Okay, so the first one here is the domain. All right, so the domain basically will tell you where the f of x is defined, correct? So if let's say the domain is from the 0 to infinity, then you don't need to worry about, from the negative infinity to 0. Okay, so that's the first thing, is to take a look at your function to see where is the domain. So where is your function is defined. Then the next things here, those are very helpful. Also, they can help you to identify the point. We say is the intercept. So we have two kinds of the intercept, right? So we call this the x-intercept, and we have y-intercept, right? So the y-intercept is x equal to 0. So basically, you want to see is the f of 0 exist, okay? Or what is the value of f of 0? Then the x-intercept, what is the x-intercept? So it's y equal to 0. What's that mean? That means if the f of x equal to 0, right? So can I find the x value? Are those x value exist or not? If I can find it, then it will give me the few points I can start to plot. Okay, then let's take a look at the symmetrics to see is my function is symmetric to the x-axis. So the y-axis, so if it's symmetric to the y-axis, what's that mean? That means the negative value of x was equal to the positive value of x, right? So you will say, hey, is the f of negative x equal to f of the positive x? Do I have these ones here? So if it is symmetric about the y-axis, then we just need to plot the one side, and then we use the symmetric property. We can find the other side, right, to the y-axis here. Now, also we say, hey, how about it's like the symmetric to the origin? That means what is symmetric to the origin mean? That means this is the negative x is equal to the negative f of x. That's right. So we say, hey, it's symmetric to the origin. So this is also is the same definition. It's like you check is the function is an even function or not, right? And then this definition is check is the function is an odd function or not, right? Then the next thing here, so is the periodicity. So it said, hey, so this function have a period. So how do we define that this function is a period? That means in here, the x plus p is equal to xp here. Does this one exist here? So it's not just for one value, this exists for all the x domains, right? So like sine, cosine function, they are periodical functions here. Okay, so the next things here we can see very easily is hey, do I have any asymptotes? Do I have a horizontal asymptote or do I have vertical asymptotes here? So the horizontal asymptote, like we talk about, is limit x approach to the positive infinity. And if this f of x exists or not, or the horizontal asymptote, you can say is limit x approach to the negative infinities, right? X exists or not. If it exists, then you can mark your graph, say, hey, those are the asymptote my graph going to getting approach to. Then the same ways for the vertical asymptotes. So you can say that when the limit x approach to a from the right-hand side, the f of x is this one equal to the positive infinity or negative infinity? Is this correct? Do I have this vertical asymptote? Or the same way I can approach to the left-hand side f of x to see, do I have, the asymptote is going to the positive or negative infinities, right? So this is how we check the asymptote. Now we say the increase. Okay, so we talk about this for the, the previous few lecture, we know the increase is, then we see what interval. So remember, how do we set what interval? So increase, what's that mean? That means f prime x what is greater than 0, right? So if you want to see decreasing, so what is that? So you want to see what interval f prime x is what? It's less than 0, right? That's what we talk about the first derivative test. Then the critical values here. So the critical value said, okay, do we have any critical values, right? So then we said, okay, so what is the critical value? So we say, hey, do I have f prime x equal to 0? Remember? Or the f prime x not exist. Both those places defined my critical value. So do I have such values here? Okay, and then we, based on our first derivative or second derivative test, I want to take a look the local extrema. That means where can I find the local max and the local mean? Right, so do I have this? All right, so based on my, the increasing, decreasing here. Then the next thing here, I want to see how is my graph bend. So I said, where is the concave up or concave down? So that means on what interval? Do we still remember how do we define the concave up and the concave down? That means it's my second derivative greater than 0, right? So concave down here, it will be what interval? Then my second derivative is less than 0 here. Does those interval exist? If it exists, then I need to know, is a concave up or concave down, so I can bend my curve. If up, you bend like this way, you bend down like this way, right? Then we'll also talk about, hey, where the concavity change, that's the inflection point, right? So that means this inflection point is where the concavity change. Right? And then the inflection point is like we said, where the f double prime x equal to 0, or the double prime x not exist. Right? So do I have all this information? And so now with all this information, you probably will be able to do a very good graphing about your functions here. It doesn't mean that every item has to be satisfied. Oh, it doesn't mean maybe some other information, your graph, you can just randomly pick up a few points in order to make your graph looks better, but with those general guidelines here. Okay, so now let's take a look at the first example here. So first example, this is the one they give you. Okay, so this is the one they give you the information here, right? So let's try to put here. Let's try to mark this. Okay, so now the first is here. Okay, so let's read through each information. So for this one's here, basically it just tells us for the informations here. Okay, so they said, hey, the first things here, they say the domain, right? So the domain is negative infinity to -1, and the +1 to the positive infinity. That means, what does that mean? That means here, that means my functions, right? So whatever this f of x function, they cannot define the in between. This is ones, right? So if I put this is 1 and this is -1. So my function cannot define the in between the -1 and 1 because my domain specifically said what my domain specifically says like is between -infinity to -1 and 1 to positive infinity. Okay, now let's try to mark our second information. So the second information is f of 2 equal to 0, f of the 2 equal to 0. So that means it's in here, right? So that means I have a point. This is a 1 point in my graph. I have an x-intercept and x2. Okay, so now this one's here, this tell you f of x. Okay, so the f of x is equal to negative f of negative x. So if you rewrite this one, basically this one you can rewrite it is like f of negative x is equal to the negative f of x. So what do we say here? This is symmetric to what? This is going to be symmetric to the origins, all right? So when we graph it, then we can just reflect it over that, okay? So right now we cannot graph it, but we know this is odd functions here. Okay, so now the next things here, the numbers part D here, they said, limit x approach to infinity, f of x equal to 4. So what is this one information they tell us? What is this information they tell us? That means what? I have a horizontal asymptotes, right? So my horizontal asymptotes here is 4, correct? All right, so I have a horizontal asymptote 1, 2, 3, 4. So that means this is my horizontal asymptote. So when I approach it, it's going to give me close to this one here. Okay, then the next things here, they said my x approach to 1 from the right-hand side, I have a vertical asymptotes here. Okay, so here, be careful here, right? So this is going to be, that means your graph going to go down, right? Because this is negative infinities here, okay? So now let's continue, right? So we got all this information. So now the next one's here, they said f prime 3 is equal to 0. So what's that mean? F prime 3 is equal to 0. That means, the f prime 3 is going to, you're going to maybe is have a critical point here. So I don't know what is the y value, I just approximate that. Then f prime 5 is here also, f prime phi is equal to 0 also. So that means I'm going to, okay, so I'm going to f phi, so 1, 2, 3, 4, 5. So I'm going to have some value here, the true. So of course I cannot get it exact because I don't know what is the function values here. Okay, so now they said, okay, so this is mark my critical value. So that means I could have a term here, right? So then they said f prime x is greater than 0. Okay, so here, take a look here, right? So it says it's greater than 0 from the 1, 3 and the 5 to infinity. So what do we mean the greater than 0? That's my function is what? My function is increasing, right? So this means my function going to be increasing from 1 to 3, right? So 1 to 3, right? So it's increasing and the 5 to infinity. So this is 5, right? So this is 5. 5 to infinity is increasing also. So I can kind of do like here. I know this is increasing, right? And also the half asymptote. So I know my function kind of going to go like this. Okay, and then also let's say f prime x from the 3 to 5 is going to be decreasing. So I'm going to have like this. I know my graph going to look like this, but which way the, you know, the how do they bend? I'm not sure yet. I just know I know the graph is look like here, and now in here you can, because this is 1, 2, 3 is increasing. Okay, so 1, 2, 3 is increasing. And okay, so the now in here, then we also have what? We also have a vertical asymptote, right? So this is 1, 2, 3, and passing to the 2. So this is my graph on this side. And now let's make sure we bend the graph correctly. So this is 1, 2, 3, 4, 5. Okay, then they say have a local maxima at 3. Okay, so this sounds good. The local maxima is the highest point, and the local minima at 5 is good. All right. Okay, now the next ones here, they tell you, let's say, hey, in here, right? The f prime x from 4 to 6. F prime x is 4 to 6 has to be greater than 0. That means it has to bend upward. Okay, so 4 to 6, right? 4 to 6 has to, that means in these intervals, right? So that means in this interval, 4 to 6 has to bend what? So the f prime x has to bend upward. And then here, f double prime x less than 0 to the 1 to 4. Okay, 4 to 6. I'm sorry, here I did. Okay, so this is not. Okay, so 4 to 6, right? So that means from here to here. All right, so from here to here, I need to bend upward. And then also it says in here, right? So it says f double prime x is less than 0 from the 1 to 4. 1 to 4 is here. And 6 to infinity, 6 to infinity is here, right? So it says is less than, so I need to go bend downward, all right? So that means this one go bend downward, and this one go bend downward here. Okay, so now I think our bending here, this one is kind of like the correct, right? So let's smooth that out a little bit. So this one is going down, so bend down here. All right, so I bend down here, right? So, okay, so it's kind of bend down here. Okay, and then in here they said f double prime 4 is equal to 0. Okay, so that means in here I'm going to have an inflection point. So this curve here, we need to rebend it. All right, so if you take a look, all right, so from the 1 to 4, is bend downward, right? So 1 to 4 from here to here, right? It's bend downward. Then after 4, they go bend upward. So this one's here going to, so 4 is here somewhere, right? So I go downward and then upward, right? So upward here. Then after the, after the 6, right? So this is the 6th here. So it continue. Okay, so here. Okay, so from 1 to 4 is downward. Then 4 to 6, right? So 4 to 6, I'm going to bend upward, right? So here, this is my inflection point. Then after 6, right, it's going downward again. So this is another inflection point. So it's downward and what? And the asymptotes here. All right. So that is what is this side of the graph. And remember, because this is refracting over to the origins, right? So we still have one last condition we did not do, is refracting to the origin. That means you're going to flip it. So now the positive 4 going to flip to the negative 4, right? So I'm going to use a different color to show you how do I, reflecting it, right? So the same way is here, the 3, so it's over to here, it's negative 3, right? So 3 is negative 3, and 5, right? So the 5 is negative, so this one will be negative 5, right? So here, okay. So my graph going to go like this, right? So it's kind of like go boom, 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 like this. And then here you're going to go like go up, then go down, and go down, and go up, here, like that, right? So that is what is my graph for here. So we'll be able to use all the information, like provided, and then we'll be able to sketch it, right? So each info, each item, they give you some information about how is this graph will looks like. Okay, so now let's stop at here for this video, and we will come back and then we will do our own information table to see how can we graph our, the functions here. Okay, talk to you later. Okay, bye-bye.